Hello everyone. This weekend I wanted to create a super secure instant messaging program. While it's not fast, it's written completely in Node.js, both the client side, which is this side, and the server side, which is over here on a server that's on the internet. So I'm going to show you how it works. Like I said, it was a busy weekend. We had dance recitals and everything else, so I didn't have a ton of time to put into it, but I had some. So start it up on my Mac here and start it up over here. For some reason, Node.js on Linux is a little bit slower, and I don't really know why, but there's obviously a lot of optimization that we could potentially do to the software. I pushed the changes to GitHub, and I'll put it in the description. So you can do get total users, I believe is a command. Let's see what happens here. It might not be the actual command. You can also do a ping, and it comes back. It takes about 1.7 seconds here, and ping. That's a server back. I've already traded keys, and I'll explain how that works in a second. But say I want to send a message from my ThinkPad here to my Mac. I'll show you how that works. Everything's based on unique IDs. The first thing you do is you do a trade keys with the unique ID you're interested in, and you can find that out by going over to the Mac and type get my UUID. It's generated when the program first opens, so that's potentially this guy's username. One thing I want to create is I want to create an alias, so I could say, the one ending in 241 is Apple, and the one ending in, I think it's 921, but yeah, the one ending in 921 is ThinkPad, so that way you could simplify actually sending a message. So we'll send a message to my Mac. And it's not fast, but we can send a message back. So there it is. How does it work? I crudely drew it up on a piece of paper here. So when the client first opens, it generates a unique ID, and it also generates a 4096-bit RSA key. The client exchanges its public key with the server. Then the server already has a key generated, and it passes back its public key to the client. Now the client is free to talk to the server encrypted, and the server back to the client. So how do we actually talk to the person? So when my Apple sends a request, it encrypts the request with the server's public key for the information that the server needs. For example, the routing. It needs to know how to get to the client. However, the message that's actually sent all the way to the ThinkPad is actually encrypted with the ThinkPad's public key. And every public key is different per friend. So the Apple has a different public key than a different computer would have, a different friend. So we send the request to the ThinkPad with our public key. The ThinkPad will then generate a key pair and reply back with the public key, relaying through the server, and then now we're free to talk. So what's this look like? So you can see here, there's a couple of different files in the crypto chat directory. You have my own personal key pair that talks to the server. You have the public private key pair that I've generated that I send the public key to the Apple. And then you have the Apple's public key. Skip that for a minute. Then you have the servers.key, which is the public private key pair I generated to talk to the server. and you have my unique identifier, which gets generated when the software loads. The node.list will eventually be a file that will carry all of the of all of the current active peers in the network. Right now it just has cryptochat.com, but the idea will be is that the node CryptoChat node server. Well, here's a good example of a message. So you can see that the command was this relay. It was from, and in this case it was from my Apple computer to my ThinkPad. Subcommand is message. And this here, this message is base 64 representation of the key pair that was, or of the actual encrypted message. So if you decrypted this, it would have, weird characters and things like that. I mean, it's encrypted with the public-private key pair, which is, I'll just print one out for you here. So we'll print the 8BF241. So this is the 4096 key pair. It's a private key. You can get the public key out of this. That's how CryptoChat works currently. Is with this private key, we can also get the public key, and this is how the messages are encrypted. So I'm hoping to build a little more. I'd like to build a website that uses straight up JavaScript to do this exact same thing for all your buddies. Create aliasing, create group chats, things like that. But all I wanted to do is I wanted to create a simple instant messaging client that was cross-platform, that used DoD standard encryption, 4096-bit encryption. And I wanted to make it publicly available so that way it was open for interpretation and checking. So hope you all had a good weekend. I'll talk to you later.